So we've got a big weather balloon here that holds 4.19 times 10 to the third liters, 4,000 liters, a big balloon. And it holds that much helium. And when the pressure is 754 torr, the temperature is 22.5 degrees Celsius, is when that volume is realized. Okay? Predict the volume of the balloon at an altitude of 20 miles where the pressure is 76 torr and the temperature is negative 33 degrees Celsius. So here we are. This gets back to your question about doesn't the temperature really change? And it does. It does. So we're going to look at this. A good practice is to underline the pieces of information and think about what they are as regards the variables in the equation that we're going to solve. So this looks like sort of V1, okay? And this looks like P1. And this 22.5 will eventually get us to T1, but it has to be converted. Okay. Then, is 20 miles important? Is that getting into the calculation? No, it's not. It's just where the conditions 2 are. And in that case, the pressure 76 torr, that would be probably P2. And the temperature, negative 33, would be T2, and we would use that to get to T2 in kelvins. Okay? And we're going to solve for V2. So here we go. P1, V1 over N1, T1 is P2, V2, N2, T2. Now we're assuming no helium leaks out. So the one thing we can do to simplify matters is to recognize that N1 equals N2. No helium got away. Even that's not entirely true, but let's keep it for simplicity's sake. So now we have our variables, and what we want to do is to, of course, solve for V2. So V2 is equal to V1 times P1 over P2, this is P2 here, times T2 over T1. Okay, a little algebraic manipulation there, not a big deal. So when we begin to plug things in, V1 is 4.19 times 10 to the third liters. And P1 is 754 torr. And T1 is equal to 22.5 degrees plus 273. And I think that's about, rounded to 3 significant figures, we could call it 296 kelvins. Okay? And V2 is what we want to solve for. And P2 is 76 torr. And T2 is equal to minus 33 plus 273, and that's what, 240? 240 kelvins. So we've made our table, and we're ready to solve. 4.19 times 10 to the third, 10 to the 3 liters, times P1 is 754 torr, divided by P2, which is 76 torr. And then the last term is T2, 240 kelvins, divided by T1, which is about 296 kelvins. And the torrs are going to cancel, the kelvins are going to cancel. The answer will be in liters, and I got the three significant figures, 3.37 times 10 to the fourth liters is V2. So the balloon expanded significantly, as you might expect, but these two factors tell you the influence of the pressure change and the temperature change. And I think you can see the influence of the pressure change is the greater of the two there.